Hi guys, Mrs. Jacqua. Unit 8 pretest. We're going to be looking at complex numbers and DeMoivre's theorem. It's my guess because we're on numbers 14 through 20, so this is part 2. Let's go find number 14. You hear the buses in the background? I can't, maybe can't. Okay, so cool. Find the rectangular coordinates for each point with the given polar coordinates. So just real quick, let's go ahead and graph what we have. We're going to go 150 degrees. This is 150 degrees. 150 degrees actually extends that way in the negative direction. Make that bigger. So then what we need to do is we need to go -2 on the negative, or in the 150. So then there's our point. Okay, but we want to find the coordinate point. So let's go ahead and look at how to find the coordinate points. X, this is going to be r comma theta. And x equals r cosine theta. And y equals r sine theta. So let's go ahead and figure out what those are because I think we have these real close. Okay, so looking at here, let's go look at 150. 150 sine and cosine are right there. This is your sine, this is your cosine. Let's come back here, put the equals there. So r is -2. Cosine of 150 is -√3/2. And sine of that is 1/2. So x equals +√3, y equals -1. So it's going to be negative, or √3, comma -1. Cool. Oh, I didn't have that part there. So pause and read and think of what I was talking about. Let's do number 15. Find two pairs of coordinates for each point with the given rectangular coordinates. So let's come back to this page. It's going to be useful. Let's come back to here. Over 2, up 2. So this is where my point is. So my polar coordinate I need to get to is there. So we need to figure out theta, and we need to figure out this distance. You ready? Okay, so r equals the square root of 2 squared plus 2 squared. Each of these parts. So r equals square root of 8. I'm going to go ahead and write this as 2 square root 2. All right, and to find theta, theta is going to be tangent inverse of the y guy over the x guy, which is tangent inverse 2 divided by 2. So theta equals tangent inverse of 1. Now I'm going to go ahead and go find my chart because my answer is on my chart. And I can look for tangent of 1. It's right there, and it's right there. But when we were looking at it, it was in the first quadrant. So it's going to be 45 degrees. So theta equals 45 degrees. So then we're going to have our polar coordinates of 2 square root 2 comma 45 degrees. Sweet. Okay, number 16, easy-ish, easy peasy. This is on your real axis, so we're going to go 1, 2, 3. To your imaginary axis, 1, 2, 3, 4, 5. So there's the graph of it. Now we have to find the absolute value of it. So the absolute value of our imaginary number is the square root a squared plus b squared. I don't know if I have that in my little notes thing. I don't, so it's fine. Square root negative 3 squared. Remember, when you square negative numbers, they always turn out positive. Square root 9 plus 25. So absolute value equals the square root of 34. All right, so this one we do have some notes associated with it, so let's go ahead and look at them. R equals the absolute value, which is the distance, and to find tangent is that guy. We've been doing it already, but these are just the formalized notes for it. Express this as a complex number. First, we have to find what R equals. Then we have to find out what theta equals. All right, so let's find R. It's going to equal the square root of 2 squared plus 2 square root 3 squared. So this is 4 plus 4 times 3. So this is square root 16. So R equals 4. Theta equals the inverse tangent of the second number, 2 square root 3, divided by the first number. So it equals inverse tangent, square root 3. I'm going to go ahead, instead of use a calculator, I'm going to go find it. So let's go look at tangent. And we're in the first quadrant again, just based off of graphing. Let's go look for square root. Here's my tangent. Here's my square root 3. We're at 60 degrees. So theta equals 60 degrees. Now let's go remind ourselves how to write this in our polar form. How do we write this in our polar form? This is our polar form. Let's kind of go put this over here. Z equals R. Go ahead and click on that. Equals R, which is 4, parentheses, cosine theta plus I sine theta. So that's our answer. Kind of fun, kind of cool. I like these. Anyway, graph the complex number on the polar grid, then express it in rectangular form. So what we need to do is we need to come and find 150 degrees, which is this one, which then naturally extends back. So that's your 150, but if we have negative numbers, we go down that one, right? And then we have 5, so we're going to go 1, 2, 3, 4, 5. So that's our complex number in polar form. And then what we want to do is we want to change this, which is really easy. Okay, so let's go to our unit table. What we need to find is we need to find 150 degrees. And we need to identify the sine and the cosine. This is the sine, this is the cosine. And then we just go plug our numbers in. So this is 5. Cosine 150 degrees is negative square root 3 over 2. Plus 1/2 I, because sine of 50 degrees is 1/2. And then we're just going to distribute the 5 through. So this becomes -5 square root 3 over 2 plus 5 over 2I. And that is our rectangular form. Sweet. All right, so here's some rules. Memorize those rules just real quick. Okay, definitely gave you plenty of time to memorize them. So here's what I want to point out. When I'm multiplying my z's, I multiply my r's and add my thetas. When I'm dividing my z's, my complex numbers, I'm dividing my r's and subtracting my thetas. Okay, let's do it. It's really easy. And I think I have both. So let's go ahead and put squiggles through here. When we're multiplying, we're going to multiply our r's. So we get 30. And we're going to do cosine. And we're going to add our thetas. 2 pi thirds plus pi 6 plus I sine. Same thing. 2 pi thirds plus pi 6. Okay, so working with that, 2 pi thirds, we want stuff in sixes, so this is 4 pi 6. So then we're going to get 30 cosine 5 pi 6 plus I sine 5 pi 6. And I'm going to go ahead and use my really super cool table. Let's go find it again. Kind of far away. Should put it like on every problem. So we're looking for 5 pi 6, which is here. Oh, we're already there. That's crazy. So this is your sine, this is your cosine. So then we have 30. Cosine 5 pi 6 is negative square root 3 over 2 plus 1/2 I. Distribute that 30 and we get 15 square root 3 plus 15I. But that was a negative 15. So there's your answer. Sweet. We're almost done, guys. Oh, let's look on this one too. So remember our rules. Our rules were, I want to stay on this webs page. Our rules were, we're going to work on the divide. Divide means we divide those parts. So we get 9 divided by 6. And then we're going to subtract the other ones. Cosine 135 minus 45. And then plus I sine 135 minus 45. Okay, so what does that angle end up being? 90 degrees. So then I have 3 halves. Let's go to my 90 degrees, dude. Let's find out what 90 degrees is. It's easy-ish. It's my 90 degrees. Those are my answers for sine and cosine. Cosine is 0. That's going to make multiplying really nice. Plus 1I. So my solution is 3 halves I. Sweet. Last problem. Oh. Yeah, last problem. This is a power one. There we go. Here's our power one. Now let's look at our power ones and look at the key components. If I have it raised to the nth power, I'm going to do r to the nth power, and my angles I'm going to multiply by n. Okay, nth power angles. And we may have to find r, we may have to find theta. Okay, so the rules are we first need to find r and we need to find theta. So r equals the square root, negative square root 3 squared, plus square root 3 squared. So it's going to be 3 plus 3. So r is square root of 6. Theta equals tangent inverse of square root 3 divided by negative square root 3. And that's going to shake out to be 45 plus 90, 135. Okay, so 135 degrees. So now we have our parts. So that means we have z equals r square root 6 parentheses cosine 135 plus I sine 135. And now all we have to do is plug in our little cool formula. We want to take it to the 5th power. So that goes to the 5th power. This goes to the 5th power. This gets times by 5. And this one gets times by 5 as well. So then I get square root of 6 raised to the 5th power. I have no idea what it is. I get 6 times 6 times 6 times 6 times 6. Pairs come out, so we get 36 square root 6 cosine. And what's 5 times 135 equals 675 plus I sine 675. Now, if we want to look for what our reference angle is for 675, 675, I'm going to subtract 360. And our reference angle is 315. So that's what I'm going to look up on the chart. Let's go find our chart. There it is. What is 315? So this is my sine, this is my cosine. Let's go back to working my problems without a calculator because I can. So 36 square root 6 cosine 315, so the same as 675. It's going to be square root 2 over 2 minus square root 2 over 2 I. Okay, so if we multiply square root 2 over 2 by I, we're going to get 18 times 2 square root 3. So we're going to get 36 square root 3 minus 36 square root 3. Oh, I lost it. Square root 3i. Fabulous, guys. So that's the rest of the test. All right. Good luck. Get her done.